So let's move on and take a look at the gallbladder. So once the liver makes and secretes bile, it is going to move to the gallbladder. The gallbladder is where it is stored until it's ready to be released and used. It is going to be concentrated. So the bile works best when it is concentrated. So that's why we need the gallbladder to go in and concentrate the bile, but not too much. We'll talk about what happens when we concentrate it too much. And then it is going to release the bile once it has concentrated it. So if we cut open that gallbladder, we would be able to see the inner mucosa is going to be highly folded. And one thing that we learned about highly folded structures like the stomach and things like that is going to allow for distension. So the gallbladder is going to fill with the bile and it's going to be able to distend, and then whenever it empties, then it is going to go back to its original position there, or I guess shape, not position. And remember, of course, we talked about how the cystic duct is going to connect the gallbladder and it's going to join that hepatic duct and form that common bile duct. But we'll talk about how you do have a sphincter that's going to go in and control the bile into and out of the gallbladder. So we'll talk about the hormones that help contract the gallbladder wall and things like that. What actually stimulates our body to secrete bile here in the gallbladder in the first place. So let's take a look at one of the problems. One very common problem of the gallbladder is going to be gallstones. So this is also called cholelithiasis. That is what that word is over there. It took me a little bit to get that out. So anytime you see this chole word, that is typically going to refer to the gallbladder. So we'll talk about inflammation, cholecystitis. We'll talk about removal, cholecystectomy. So anytime you see those, that cholecyst or anything like that, that is going to refer to like the gallbladder, which is going to be important when we talk about CCK, or cholecystokinin, where that is going to obviously be the one that controls the gallbladder here. So with gallbladders, they typically are going to, of course, form in the, with gallstones, they form in the gallbladder, and or the biliary apparatus. They can also become lodged in there. Typically what gallstones form from is going to be whenever the gallbladder concentrates too much, and it's going to condensate into cholesterol. So most of the time, whenever we do have gallstones, they are typically going to be cholesterol stones. But they can be calcium and bile salts as well, but the most common is going to be cholesterol. So a lot of times individuals can be asymptomatic. They might have a little bit of nausea here and there, but they really don't think about it because they don't, they think they ate something bad, or just their stomach didn't agree with them. But over time, if the gallstones get lodged eventually in that cystic duct or in the common bile duct or anything like that, then what happens is that as you can see, if it gets lodged in here, the bile is not able to empty like it needs to. So it will it will stay in here and it will cause inflammation, and eventually the gallbladder will become inflamed, and that's where that cholecystitis is going to come from. So that's when you typically have severe pain, and it's usually going to be in the right hypochondriac region, or you can also have pain in between the shoulder blades as well. And sometimes individuals that have severe pain in between their shoulder blades think that they're having a heart attack, because that is another place where heart attacks are felt. But when actually it is just a gallstone attack. And I don't want to say just a gallstone attack because they can be quite painful. So other symptoms that can happen: nausea, I talked about, vomiting, indigestion, bloating. Usually these are going to feel a lot worse after you eat a fatty meal, because the body is going to sense that fatty meal that goes into the duodenum, and that's whenever it gets the trigger, oh, we need to release bile. So that hormone is going to go in and cause the bile to contract, but it can't release any of the bile, so that's why it's going to worsen after that. So usually they are going to go in and just remove the gallbladder, and that is called cholecystectomy. And again, since bile is going to be secreted from the liver, it's not like you're never going to be able to break down fats. It's going to be a little bit harder, so that's why they tell you to watch your fat intake after you get your gallbladder taken out. It's because of the fact that you're not going to be able to break down fats as efficiently. Because remember, in order to break down fats, you need a more concentrated bile, but the liver secretes a diluted bile, and that's better than nothing. So it will go in and still break down some fats. But if you do eat a high fat meal and you don't have your gallbladder, then typically you have to go to the bathroom very quickly after that, because the fats tend to stay inside of the intestine wall, and so does a bunch of water as well. So I think you kind of get my idea of what might happen after that. All right, so the other accessory structure that we're going to talk about organ is going to be the pancreas. And as you can see, here is the picture of the pancreas down here and where it lies. So it kind of gives you an idea of where there's that duodenum, and of course the duodenum, the stomach is going to be attached right here, and then there's that pancreas. So it actually kind of sits posterolateral to the stomach. The pancreas, you might remember from chapter 17 in the endocrine system, where we talked about how it has a major endocrine function. It produces and secretes insulin and glucagon, which is very important in regulating our blood sugar levels. However, what we're talking about here is a major exocrine function here. It is going to produce pancreatic juice, and we'll talk about what is going to be in this pancreatic juice here in a second. And it is going to be there. It is going to be key enzymes and secretions that are going to be essential to digestive activities. This is another one of those organs that's retroperitoneal. All right, so let's take a look at the histology a little bit of the pancreas. So this, if we take a look at, this is a pancreatic islet, and you might remember this from the endocrine system, because this is going to be that structure that has those alpha and beta cells that is going to secrete the insulin and the glucagon. Well, we're not worried about that. We are looking at the pancreatic acini, and that's going to be everything else here. About 90% of the pancreas is going to be made up of these acini cells here. Acinus is going to be singular. There it is. Acini is going to be plural. So as you can see, they're kind of modified simple cuboidal epithelial cells. You can kind of see them here. So these acinar cells are going to secrete very important hydrolytic enzymes. They are going to secrete amylases. We've already talked about one, so we know what that breaks down. It's going to help break down more starch. It's also going to break down our key fat enzyme, which is going to be lipase, pancreatic lipase. And we'll also talk about some proteases and nucleases that's going to secrete as well. These little duct cells down here, you can see these right here, those are going to secrete bicarb. So the pancreatic juice is going to be a very alkaline fluid or solution, because it is going to secrete that. So here's our pancreatic juice. Again, it's formed from the acinar cells and the duct cells. It's an alkaline fluid, mostly water, bicarb, hydrolytic enzymes. Again, we just went through these. Amylase, lipase, inactive proteases. We'll talk about these in the very last section on, we talked a little bit about why they're released. The proteases are released in an inactive form when I talked about pepsinogen turning into pepsin. So we'll talk about that a little bit later in the last section. And also, of course, the nucleases. So let's talk about how our body is going to regulate these secretions that are going to come from the liver and the pancreas and the gallbladder. So the ones that we're going to focus on is going to be CCK and secretin. We actually already talked about gastrin, so we're not going to be looking at this. We are going to look at, these are going to be hormones that regulate the accessory structures here. So let's first talk about cholecystokinin, or CCK. Again, there is that cholecyst word again, so that is going to refer to the gallbladder. But it actually is not going to only target the gallbladder. It's going to target other accessory structures. So the thing that actually stimulates the release of cholecystokinin is going to be when that chyme enters into the duodenum, it is going to, these chemoreceptors are going to pick up that it is high in fats and also amino acids. But really one of the key things is going to be fats here, because what that does is it is going to trigger the smooth muscle wall layer in the gallbladder to contract. And that is going to go in and stimulate the release of bile. And again, we will talk about the importance of bile and breaking down fatty acids. Another thing is going to happen is it is going to stimulate or it's going to target the pancreas, and it is going to stimulate it to secrete an enzyme-rich pancreatic juice. So since it's getting that word in that there's still proteins and fatty acids and some undigested carbohydrates or starches in there, then it is going to start to release that to start breaking down all of that material. Another thing it's going to do is it's going to relax that hepatopancreatic sphincter, which is really important if you think about it, right? Because that's going to allow the pancreatic juice and the bile to be released into the small intestine. So we can have that smooth muscle contracting the gallbladder all we want, but we need that sphincter to relax to open up the way for the bile and the pancreatic juice to get into the small intestine. Another one is going to be secretin. This is another important hormone that is going to be secreted from, and the thing that's going to stimulate its secretion is going to be pH. And this one is going to be primarily, it's going to sense the acidic chyme that's coming into the duodenum. So obviously if we want to buffer this, it's going to trigger the pancreas to secrete its alkaline solution from those pancreatic ducts. And it's also going to cause the liver to secrete an alkaline solution as well. So that's going to help neutralize the pH and the duodenum, which is really, really important to make sure that we don't keep that pH at 1.5 to 2.5, which would completely destroy our intestines. We need to get back to neutral, to where we need it to all of those, the new enzymes that are coming in need to be able to work, and they do not work in an acidic environment. The only enzyme that works in an acidic environment is going to be pepsin. And we'll talk about another one here later on that works in a slightly acidic environment as well.